Hi, I thought what I would do to kind of talk about the analog to digital converter module a little bit is to look at the data sheet of ATmega 328. So this is the data sheet. This data sheet I have put on Moodle, so you should be able to download it. And if you download it and look at the bookmarks, you have the table of contents here, and I'm going to be looking at chapter 24. This is the analog to digital converter. And of course, you can read all this material, and that kind of describes how this module works. But I'm just going to look at the register description, which is kind of a summary of how each register is functioning. And what this would give us is it would tell us which registers are important in setting the ADC and how these registers are actually controlled. So let's take a look at that. So if you look at the register description, the first register that we have is called AD-MUX here, right? AD-MUX is the ADC multiplexer selection register. So if you remember, I said that ADC can have various inputs, and this ADC mux selects one of those inputs. So let me just show you that. So take a look at these four bits here. This is mux 3, mux 2, mux 1, mux 0. So what do they do? So I just go down here and it says bits 3 to 0 are the analog channel selection bits. And if you look at the table here, they tell you what that means. So if the value is 0000, it selects ADC 0 as the input for your ADC. The analog input that is coming at ADC 0 is going to be converted. And similarly, if you have 0100, you are using ADC 4, which is one of the pins in your microcontroller, and the analog input that comes there is converted into a digital value. Okay. There are more bits in this register. What do this ref S1 and ref S0 do? So and that is explained here, right? If ref S1 and ref S0 are 00, the voltage reference to your ADC is basically whatever analog value you give at this pin called a ref in your microcontroller. If ref S1 and S0 are set to 01, then it uses a VCC, which is basically the power supply to the microcontroller, which is used as the reference. And in most cases, we would just want to use this as our reference. So we would set ref S1 and ref S0 as 01. We have another bit called ADLAR, and we'll just discuss ADLAR in a moment when we discuss some other registers. Okay, so basically you will have to set the values of these registers depending on what you want to do. So most often what we would want to do is we'll just set RF, so this at 01. We'll talk about ADLAR in a moment. And then we might just say, well, we'll use ADC 0 as our analog input. So we set mux 3 to 0 all at zeros. Okay. So that's the first register we'll have to manipulate to set our ADC to do what we want to do. Then we want to set the ADC SRA, which is the ADC control and status register A. There are two such registers, register A and register B. Excuse me. Okay, so in ADC SRA, the bit 7, the first bit is ADC enable, which just switches on the ADC. If this is 1, it says writing this bit to 1 enables the ADC. By writing it to 0, the ADC is turned off, right? So we want this to be on when we want to use the ADC. ADSC is a bit called ADC start conversion. If you write 1 here, the ADC starts doing a conversion, especially when it is in the single conversion mode, which means that you just want one value to be converted into a digital value. But you could use a free running mode, which means that the ADC does one conversion and then immediately after that it starts another conversion, and then it starts another conversion as soon as that is finished, and so on. So it continuously keeps converting analog values to digital values. And if that is the case, then ADSC just you just set it 1, and basically it just continues doing the conversion. Okay. A date is uh, a bit that you use to enable auto triggering of the ADC, which means that some other module of the ADC controls when the analog to digital conversion happens. And we'll just talk about it in a moment again. Uh, we will leave ADIF and ADIE. These are related to the interrupts, ADC interrupts. We have not discussed interrupts yet. The next module after ADC that we discuss is interrupts, and we'll come back to this then. But just as a um, as kind of a teaser here, we can enable ADC interrupts using this bit ADIE, and this is the ADC interrupt flag, and we'll talk about that. Okay, then we have the last 3 bits, which is ADC prescaler select bits. Remember, we talked about the ADC prescaler, and we said that uh, from the system clock you can derive an ADC clock. Okay, and you can have different division factors, and you can set these. You can select the prescaler for those values. The output of the ADC is stored in ADC-L and ADC-H, as we looked at before, and they are the output of the ADC is a 10-bit output, and that's why we need two registers, because each register is only 8 bits in length. And AD ADLAR, or AD left adjust register, which was there in AD mux, remember? So let's just go back to AD mux and let me show you that. So ADLAR is this register, and depending on whether it is 1 or 0, the 10 bits output of your ADC is arranged either like this or like this. Okay, so the ADC 9 comes here if ADLAR is 1. Otherwise, it is basically it starts with ADC 0. I would suggest that in most cases you want ADLAR to be 1, because then what you can do is, if you don't want to read all the 10 bits, but you just want to read 8 bits, you can just read ADC 9 to ADC 2 and ignore these last 2 bits, because they are the least significant bits in your ADC value. Okay, let's continue and look at ADC SRB, so the ADC control and status register B. So here the important bits that you need to understand is 2 to 0, and really we'll talk about this a little bit later, but this is basically, you remember in one of the previous registers we talked about auto triggering, enabling auto triggering, and you can see that this kind of decides which of these sources would trigger your ADC. So you could have the free running mode when you set all of them to 0. The free running mode basically means the ADC starts a conversion, it finishes it, and immediately starts another conversion, and then immediately starts another conversion, and so on. Or you could say, well, the trigger source can be the analog comparator. The external interrupt means some external signal controls when the ADC starts the conversion. Or you could have these timer 0 or timer 1 control the ADC, and we'll talk about this a little bit later. Okay, so we have talked about 4 registers: the ADC SRB, the ADC L and ADC H, which is where the data of the ADC is stored, and then we talked about ADC SRA and the AD mux. So these are the 4 registers that you need to set so that your ADC can operate in the way that you want it to operate. In the next video, we'll look at a practical example and see how this works.